Hi class, today is lesson 4-3. It's on the greatest common factor. Let's go ahead and take a look at the purpose. The purpose is to find the greatest common factor of a set of numbers. Let's take a look at the definition here. The definition the term I want you to write down and its definition is greatest common factor. Greatest common factor. The greatest common factor is the largest factor common to all numbers in a set of numbers. What do I mean by that? Well, let's take these two examples here. We have 12 and 18. With 12 and 18, we have found all the factors of 12. 1 times 12, 2 times 6, 3 times 4, those are factors of 12. 1 times 18, 2 times 9, and 3 times 6, factors of 18. What do they have in common? Well, they have 1s, of course, in common, 2s, 3s in common, and 6s in common. Are there any other factors which they have in common? No. So they have 4 factors in common. So now we're looking for not just the common factor, but we're looking for the greatest common factor. The greatest common factor that they have together is a 6. So 6 is the greatest common factor of 12 and 18. Let's go ahead and find the greatest common factors. There are 3 different methods in which we could do it, and the first method we just saw, which is simply listing. So here we have 16 and 24, and it says find the greatest common factor, GCF. In this case, we're listing. So 16 and 24. Using that rainbow method, I'm going to say it's 1 and 16, 2 and 8, and 4 times 4, so I'll just put 1 4 there. Close the parenthesis. For 24, I'll go ahead and list it as 1 and 24. 2 and 12. 2 times 12, of course, is 24. There's 3 going to it, absolutely. 3 times 8. And then 4 times 6. And there's no other numbers in between 4 and 6. So if we look at the common factor, we see that they both have 1s, they both have 2s, they both have 4s, they both have 8s, and there's nothing else that they have in common. The biggest number that they have in common, the greatest, is the 8s right here. So the greatest common factor, GCF, equals 8. Let's take another look at another method, and this is prime factorization method. In this particular situation, we're looking at 12, 24, and 32. So we're going to go ahead and write 12 at the top of our tree. We're going to write another tree with the 24, and then we're going to write another tree with the 32. We're going to go ahead and go through the prime factorization. 2 times 6. Here we have a 2 times 3. In this case, this is a prime number, this is a prime number, and this is a prime number. So we have 2 times 2 times 3. Next, we have 24. Same sort of thing. I'm going to start with a prime number, 2 times 12. And this is going to be 2 times 6, of course. There's a prime number. We can continue to take 6 down to 2 times 3. And look at this. We've got 2 times 2 times 2 times 3. And for 32, we've got, we'll do 2 times 16. That's a prime number. I'm going to do 2 times 8. 2 is a prime number. This is 2 times 4, prime number. And this is 2 times 2. So all prime numbers here. So here we go. We go 2 times 2 times 2. We've got how many 2's? We've got 5 2's. Times 2 times 2. As we look at this, what do they have in common? Well, they have these 2's in common. They have these 2's in common. And there's no more 2's because, but they do have 3's. No, they only have 3's in common. Between these two expressions. So that which they have in common is 2 times 2. And 2 times 2 equals 4. So the greatest common factor of all of these numbers is 4. GCF equals 4. That's the prime factorization method. The next method is the ladder diagram, which we've seen in the past. But this time, instead of putting one number inside the ladder, we're going to put all three numbers. Check this out. We're going to put 12, 18, and 60 in this ladder. So when we go ahead and choose our first prime number, remember you're only using prime numbers when you're doing the ladder, I'm left with, well, 2 goes into 12 6 times, 2 goes into 18 9 times, 2 goes into 60 30 times. As I look at this, I know 2's can't go into it anymore, but these numbers are all divisible by 3. So 3 goes into 6 twice, 3 goes into 9 3 times, 3 goes into 30 10 times. Now, is there a prime number that goes into both 2 and 3? No, these are already prime numbers, so we're done. The greatest common factor then is 2 times 3, which is 6. So the greatest common factor equals 6. 6 goes into 12, 18, and 60, a common factor, and it is the biggest factor. Now we have one last problem to solve, and in this case it's a story problem. It says there are 12 boys and 18 girls in Mrs. Ruiz's science class. The students must form lab groups. Each group must have the same number of boys and the same number of girls. So we've got to have an equal amount of girls in each group and an equal number of boys in each group. They don't have to be the same. There doesn't have to be the same number of boys and the same number of girls in each group. Just they have to be spread out. What is the greatest number of groups Ms. Ruiz can make if every student must be in a group? First of all, I might take and I might say, well, let's put 1 boy and 2 girls in each group. So we're still looking for the greatest number of groups. Greatest number of groups is what we're looking for. I'm going to put 2 boys, 1 boy and 2 girls. So boys, we have, well, if that happens, we've got 2 girls for each group. There we've taken care of 4 girls. We are going to put another boy, another 2 girls, boy, another 2 girls. So far we've got 4 boys and we've got 12. Well, maybe I have 12 groups here. Let's see. 2 girls per group. Continuing. Looks like I have 2, 4, 6, 8, 10. 12. So here's the different groups. So far we got 1, 2, 3, 4, 5, 6 groups. Let's put some more down here. 2, 4, 6, 8, 10, 12, 14, 16 girls so far. And now we have 18 girls. 18 girls indicated as a total up here. So we've got 2, 4, 6, 8, 10, 12, 14, 16, 18 girls all taken care of. Do we have all the boys taken care of? 1, 2, 3, 4, 5, 6, 7, 8, 9. We only have half the boy, 9 of the 12 boys taken care of. There's going to be some groups with extra boys in it. 9 out of 12 means we've still got, we still have some boys to contend with. How many boys? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3 boys are still left here. So that's not the way we want to go about it. Let's go ahead and clear that. Let's think of this in terms of greatest common factor now. The greatest number of groups. Well, let's take 12 and 18 and figure out what the greatest common factor is. And it'll actually lead us to the answer. We have 1 and 12, 2 and 6, and 3 and 4. And then we have for 18, 1 and 18, 2 and 9, 3 and 6. Well, we have all these factors in common, 1, 2, 3. No 4s. We have the 6s that we have in common. In fact, the 6s are the biggest one. So this actually helps us and tells us that we can actually have 6 groups. 6 groups, well, 6 groups of how many boys, how many girls? Well, in this case, if we have 6 groups, and I'm going to make 6 groups here, it means we have, well, 12 divided by 6 is 2, so we're going to have 2 boys in each group. We hope there's none left over, and I can pretty much guarantee you there won't be using this sort of a method. And then the girls, well, there's going to be 18 divided by 6 is 3, so there's going to be 3 girls in each of these groups. Now check that out. We have a total of 18 girls represented in these 6 groups, and we have a total of 12 boys represented. And we've maxed out on the number of groups we have. So this is the greatest number of groups we can have. And how did we solve that? We solved it finding the greatest common factor. Of course, you can use the list method here. You could use the factor tree method, or you could use the ladder in order to find this. But the greatest common factor gives us the greatest number of groups. Now it's your turn. It says find the greatest common factor using the list, prime factor tree, and ladder methods. Those 3 methods that you saw. I want you to solve for the greatest common factor with 18 and 27. That's right. I want you to show 3 methods using these 2 numbers. All right, we'll see you in class.